Have you ever wondered why a dropped glass shatters, but the shards never spontaneously leap back together to form a glass? Or why iron rusts, but rust never turns back into shiny iron? The universe plays by a strict set of rules about the direction of time and energy. We call this spontaneity. It's not about speed, it's about possibility. On the screen, notice the ball at the top of the hill. It has potential. As it rolls down, it releases energy. This natural tendency to move to a lower energy state is half the story of how the universe works. Enter Josiah Willard Gibbs, the man who gave us the formula to predict the future of any reaction. The equation is delta G equals delta H minus T delta S. Think of this as a cosmic balance scale. On one side, you have enthalpy, the heat energy. On the other, entropy, the measure of chaos. The temperature acts as a lever, magnifying the effect of chaos. If the scale tips negative, the reaction happens. If it tips positive, the universe says no. Watch how increasing the chaos side tips the scale in favor of the reaction happening. Just because a reaction is spontaneous doesn't mean it's fast. A diamond will turn into graphite spontaneously, but it takes millions of years. Why? The activation energy. Look at this energy profile. The reactants start on the left. To get to the products on the right, they must climb a hill. If the destination is lower than the start, as shown here, we release energy. This is an exergonic reaction, the engine of life, burning fuel to create motion. If the destination were higher, we'd need to push it uphill. Let's zoom in on entropy, the S in our equation. Why does gas expand to fill a room? Why doesn't it stay neatly in the corner? It's simply a game of probability. There is only one way to be perfectly ordered, but there are trillions of ways to be messy. On screen, watch these particles. Initially, they are confined, ordered. When the barrier removes, they explore every possible microstate. This spread, this increase in randomness, often drives reactions forward, even when they absorb heat. Disorder is the natural state of things. If the universe tends toward chaos and low energy, how do we exist? We are highly ordered structures. The secret is coupling. Biology cheats the system. We take a highly exergonic reaction, like breaking down food or ATP, and we harness that energy to drive an endergonic reaction, like building DNA or moving a muscle. Look at the pulley system. The heavy weight falling, releasing energy, pulls the lighter weight up, storing energy. As long as the net change in Gibbs free energy is negative, life goes on. Equilibrium for a living cell means death.